Okay, so in the last video we installed Python and I wrote my first Hello World program, which just looks like this. It's just one line of code, print Hello World. Now that really is the extent of my Python knowledge. So if I run that program, just Hello World. Now I'm intending to learn Python, and I think the best way to do it is to learn by actually writing some useful or semi-useful program. Now in the Java project series I wrote this Bach program which plays a Bach tune by reading a instrument file and then plays the tune by looping through the tune object and picking out the notes and playing the tune. Now I'm going to try and implement that in Python. Now I've got no idea whether I'm going to succeed or not because I don't know how difficult it's going to be, but I'm going to have a go. So the first thing I'm going to do is go through the Java program and just comment in the Python class about the sort of things that I'll need to learn in Python to make it work. So I'm just going to go through all of the classes in Java and just write down everything that I think I need to be able to do in Python before I can write this program, and then I'm going to go and learn how to do all those things, and then I'm going to see if I can put the program together. I don't know if this is going to work out, so wish me luck, but here goes. So let's have a look at what's in the Java classes. Okay, so I found out the things that I needed to learn in order to make the Bach tune program in Python, and then I went on a mission involving Google to find out how to do the different things. So this little presentation here will go through the things that I found out. So firstly, I wanted to know how to do objects and classes, methods and properties. So here we have the Java on the left and the Python on the right. So we've got my class defined that has a parameter inside it, and it also has a method inside it. And from the main method here, we create the class, we set the parameter to be hello world, and we call the method which says my parameter is hello world. Now some differences. In Python we have the class and the method. Now we always seem to put self into as a parameter of the method, but it just gets ignored, and I'm not sure why we're doing that, but maybe at a later date I'll realize there's a good reason for it. But every method always has self as one of its parameters, but when we call the method, for example here we're calling my method, we don't provide anything, so self just goes into there. And it can be referred to. Self is the equivalent of this in Java. Now the other thing, instead of using curly brackets, we seem to be using indentation. Now I've got another slide a bit more about that, so I'll go back to that. And the other really quite unusual thing is here we create the my class, we don't have the new method. And we don't actually say what type of object one is. We just define it to be my class, so it doesn't seem to matter. We don't, in Java we would say my class object one equals new my class. In Python we can just say object one equals my class. And similarly, strangely, for a Java programmer we can just define param in object one to be hello world, but nowhere at compile time is the param defined as being in the class. We just put it in there, and then when we call my method, because it's a instance variable for the class, it's self.param. So it seems that we can just define parameters and they just spring into existence, and their types also just spring into existence when we define them. So there's a few differences there between Java and Python. Right, so I said we were going to have a look at the indentation. So indentation is important in Python, whereas in other programming languages it's just there for code readability. So Python uses indentation to indicate a block of code. So I did some experiments, and if we put a hello world method indented level with this print line, if we do a print hello world, then it will be part of this method. But if we bring it back, then it will not be part of this method and it will be part of the main code. So indentation is important. I also did the experiment, and just one space is enough to be classed as being indented. Okay, next, the constructor. Now in Java, the constructor has the same name as the class, and it has no return type. The return type is actually the object itself, but we don't define a return type. So here's a constructor with a string param. Say this param equals param. In Python, the constructor is 2 underscores, init 2 underscores. Now this is equivalent code, so we're passing one parameter in. Like before, the strange Python things, we're not saying what type param is, and we're setting self param to be this param, even though we haven't specified that there is a self param. So that is the equivalent code. So we have self instead of this, we have init instead of the class name, and for methods we put def to define the methods. Also, instead of curly brackets we use colons to go into blocks of things. Now when I was looking at this, I was also looking at method overloading, because I was interested to know whether we could have several different constructors. Now it turns out method overloading in Python is slightly different, where we still have only one method, but we can have optional parameters, and I think it goes in the order. So we can either have method with the first parameter, first 2 parameters, or first 3 parameters. I'm not 100% sure how this works, but I don't need to know now. But it's interesting that Python does this slightly differently, whereas in Java we would have a whole nother method. That whole nother method might call the original method with null or something like that, but it looks like Python does it differently. We have just one method with the parameters, and the optional parameters equals none, and that's how we do method overloading in Python. I don't actually use that in this project. I was just interested at this stage in my learning to find out how we do method overloading. Now method returns. Now this didn't surprise me at all at this stage, how we do method returns. So in Java we specify that the my method will return a string, and then we return the return string. And in the main method we're building the class, and we're just system out print lining the result of my method, so that would just system out print return string. In Python we've got the class, the method. What didn't surprise me is that we didn't have to define that we were going to return a string. We just return what we want when we want. So object 1 is my class. I haven't specified that what object 1 is, but it's my class, and we print the return of the method. So that's equivalent code again. Now I came across the none keyword in the method overloading thing, where we had optional parameters and we could say it equals none. Presumably in the method overloading we could say it equals something, but none is basically null, so these things are the same. So private string my nothing equals null, and in Python just my nothing equals none. Now, of course, we got no idea what that will be when it does become something, whereas in Java we know that it's either a string or null. But that's another difference. So in Python we have none, in Java we have null. And then this is how much of a Python amateur I am. I didn't even know whether we could define classes in different files, but I assume we could, because we're not going to have one Python program in one big long file. But the way it works again is slightly different. I think there's a slightly different way of thinking of things. So in Java we have packages, my other package, and in that package we have classes, my other class. And in this class, which is in another package to my other package, we can import it because it's not in the same package. So we import it with the package name and class name, and then we can use it just by class name. In Python it seems that we say from my other package, my other module, import my other class. Now a module seems to be equivalent to one file, so we can have several classes defined in my other module, which is in my other package, and then we can use it by my other class, which is what is on the right hand side of the import method. I believe we could say from my other package import my other module dot my other class, but then here when we refer to my other class we would have to do it as my other module dot my other class. So what goes here when we're specifying the class is whatever's on the right hand side of the import. Okay, so for a for loop, in Java we have the initial value of, or the thing we do at the start of the for loop, the check that we do to see when the for loop should end, and the thing that happens in between each iteration of the loop. So this will print 1, and then because we're adding 2 on each time, it will print 1, 3, 5, 7, 9, and then x is not less than 10, so it will terminate there. The same thing in Python, but this time we say for x in range, the initial value, the terminating value, and the step value. This step value is optional, and it would be 1 if we just had 2 numbers in brackets. So that's the equivalent for loop. And for threads in Java, we have a thread which implements, or we have a class that implements the runnable interface, and then we create a thread class with that class added to its constructor, and then we call start of the thread class, which then calls the run method in the runnable class. In Python we have to import threading. We would have to import something for Java as well, but I can't remember what it is. But we import threading, class myThread, and then in brackets threading.thread. Now this is actually inheritance, but we'll have a look at that a little bit more soon. Then we define the run method. We have the self parameter as we always would, and that's going to print running as the Java did. And then we can say thread equals myThread, thread.start. So it's similar, but we don't seem to have the runnable interface. We just create a class that extends thread. And yes, so it was looking at that thread that made me realize that that was inheritance in action there. So here we have a class defined and a my other class, which hasn't got anything in it, but my other class extends my class. So this instantiating my other class, and we call my class method in class, that's inheritance in Java. In Python we put the parent class in the brackets of the child class, so we say my class, there's the method defined, printing my class method, and then for the child class we say my other class, in brackets the class that it extends. Now I had a compiler error here, so I just put none keyword in just to make it compile. And so this is doing the same thing as this. It creates a my other class, but it calls the my class method in its parent class. So that's inheritance in Python. Now playing sounds, I'm not going to go through this, but this took a bit of messing around to get the play sound method to work with frequency and timing. This method is good. I did try 3 or 4 different ways, but there's one thing to say about this, and that is I had to import some libraries. And the way I did that in Eclipse was I went into Eclipse preferences. I went into the preferences for PyDev, interpreters, Python interpreter, and then manage with pip, and you can install packages. And I was sort of guided to what the packages that I needed according to the code that I found in Google, but I eventually imported simpleaudio and NumPy, which is doing some number functions. I think it's creating some arrays in there. This Python play sound method, I can't really say I wrote that myself. It's taken from something I found on Google. It does a job. It will play a sound for a frequency, and then the method will return when that's finished. So that's the stuff I found out, the stuff I'm going to use in the Python program. So let's write our Java back tune program. Let's port it to Python. Okay, so I'm not sure whether this is worked out quite a bit easier because Python's easier, or because I'm doing it in a bit more of a simplified way. So in the Java class, I had an instrument object that read a raw sound sample file, and then I had different voices, and I had a separate player and channel object. Whereas in this version, I'm just calling winsound.beep to play the sound. But I think I've pretty much finished the structure of the program. What we do, we just have 2 files back, and that is just importing all of the tune related stuff from the tune file, which is in the Kirkwood.Bach package. I may be talking in Java terminology here, but from Kirkwood.Bach import tune, I'm creating a back tune object, and I'm calling play tune. Now we have 3 classes in here. The back tune extends. I think I need to put what extends in brackets if I remember rightly. Yeah, that's right. So back tune extends tune. Now I'm going to try something which you can't do in Java, but I think you might be able to do in Python, and that is call this is a constructor for tune. I'm going to call the constructor for the superclass as the second line up and see if that works. And I'm creating a list of notes. We'll look at what a note is in a minute. So the tune, it just sets itself .notes to be notes. So that's the equivalent of this .notes equals notes. Although we don't have to define what notes is. It is an array of notes. And then there's a play tune method for note in self.note, note.playNote. And then this is a note method. Now, instead of having a separate player and channel that we had in the Java program, we just do winsound.beep, and that's also going to handle the duration. So this program is really much more simple. So the note has a self parameter as always, and then it has note, octave and duration. and it just saves those parameters. And then when we play the note, we get the frequency, which is bass note, which is just some frequency to tune everything up. And then for X in range 0, it doesn't matter what X is not used, but can we just say for range, I wonder? For range 0 to the note plus the octave times 12. I think I've got an error here. Can I just say for in range? Maybe not. Okay, it's telling me that X in this for loop is an unused variable, but it has to be there just to loop through. But so there's almost definitely a better way of doing this for loop here, but I don't know what it is at this stage. Anyway, the frequency, this semitone value here, for each key we want to go up on a piano, we multiply the bass frequency with this frequency, and that is covered in the other video, but it's to do with equal temperament. So and it's really just the frequency of each increase note as we move up a piano. So the notes are defined as integers, and they're defined as constants here, and this is note C sharp, note D sharp, all the way up to note B, and then an octave is the next note up, so we multiply the octave by 12, which is 12 notes up, and then we add on the note, and each time in that loop we multiply the frequency by this semitone value, and that should get us the frequency that we want. And then we win sound dot beep for the frequency and the duration. Now I would be pleasantly surprised if this works, but what I'm asking it to do is play a note C in octave 1 for 1 second, note D in octave 1 for 1 second. In case you're not sure, music is relative really, so this bass note could be anything. This tune may not necessarily be in tune to some other instrument, but it should sound good relative to itself. So let's give this a try. Okay, so it didn't work, which isn't really surprising as it's the first decent program I've tried to write. But what have we got? Most recent call left. Integer argument expected got float. Okay, so the value that we've, the frequency that we're passing into win sound needs to be an integer. So hopefully we can cast float to int. Because it's a big number anyway, it won't really matter if we just convert it straight to an int. Safest way to convert float to an integer in Python. Mass.floor. Oh no, this is the question. Just int in brackets now. Int and then the parameter in brackets. That seems like, where is this int defined? Is it a method, or am I thinking too much in Java? But anyway, I think we do int. Is this like a? Is that a method, or is it just casting? It's built-ins. Okay, well let's see if that's the only problem we've got. Back to back and run back. Okay, so that works, but the frequency is too high for octave 1. I don't want to tune, I want to run back. And then there was like a double thing there, so let's try 200 as the bass note. Again, I think I need to up the frequency a bit. No, so this winsound.beat method is not suitable really for this task. So I'm going to see if I can find a better library to do it. After a bit of messing around, I eventually find the simpleaudio package on the Real Python website. Do we need simpleaudio as well? Let's just copy this and see what errors we have. So we were putting the sound player in this tone player class. Numpy, simpleaudio. Numpy doesn't seem to be an error. So do I need to import simpleaudio? I don't seem to have an error on Numpy, so I'm going to try and see if I can do, oh there it is, I've apparently installed that. Did I do that earlier? Simpleaudio. Successfully imported simpleaudio. Now can I run this? I think I've got an error. No, it works. Okay, so I've managed to make a play sound method which is defined in this tone player class, which takes frequency and milliseconds. It's using this numpy number pi library and simpleaudio and time. Now I had a few problems with this, but I eventually got it to work. I don't really completely understand what it's doing. It's making a sine wave using the numpy library, and then it's converting that into the correct format to play here. This is giving us a play object from the simpleaudio library, and we can terminate the note with that. Now I couldn't get this note to play for the right amount of time, but what I can do is time sleep, which is the equivalent in Java of thread.sleep, for a certain amount of time, and then we can just cut off the sound. So now if I go back to my tune, here are the notes for the back tune. I've set a frequency of 200 milliseconds per note, and I think I tweaked the bass note to be in about the right range. And now we can play the first part of the tune. And now all there is to do is stick in the rest of the notes, and then we should be good to play the tune. So I'll do that now. Now what I can actually do to generate these notes is go back to the Java program, and I'm going to actually modify the Java program to output this code. In fact, note length is always the same. No, I'll just generate the code like this out of the Java program. Save me typing in all these notes, so I know it's going to get quite confusing. So here's that. Okay, so here is the finished tune. It went wrong at the end because there's a 3-note chord and we've only got one voice. But that's it for now, so thanks for watching.